Assalamu alaikum. This is Kesin Ayam. Today I'll show you how to create this infrastructure, like how to create a VPC, and inside a VPC we will create one public subnet and one private subnet in a availability zone, and one public subnet and one private subnet in another availability zone in same region. And then we'll connect all the subnets using route table, and we will connect private subnet with the public subnet using NAT, and we will connect public subnets to the internet using using gateway. Okay, so let's see how we can do it in AWS. So we'll go to VPC to create a new virtual private cloud. Your VPC, then it is a default VPC. When we are creating we are creating a AWS account, this default VPC always there, and when we are doing something like we are creating a EC2 instance, it will be created in this default VPC. Now we will create a new VPC, and we will do our work there. So I'm clicking create VPC, then VPC only. We can do this using VPC and more. We can do all the steps using one click, but for learning purposes we will do this now one by one. So VPC only, let's do this KCVPC 01, just KCVPC, then IPv4. I have to specify the VPC's CIDR range for private IP. I will do the 10.0.0.0 slash 24 now 16. So we will have we will taking this CIDR range. Okay, no IPv6 CIDR block, tenancy default. Okay, we'll create this VPC. In this VPC we will have 8 into 8 to the 16 subnets, which is 65 subnets, hosts. We can have 2 to the power 16 different IP addresses, which is 65,536. Okay, we have created a VPC. Now we have to create subnets inside that VPC. We have created this RAID zone. Now we have to create these subnets. Okay, now create subnet, then VPC ID. Okay, well, we have to select in which VPC we will create the subnet. So I'm selecting KCVPC, then this is VPC CIDR range. So this is, and okay, now it's first subnet. I'm naming this KC public subnet, KC public subnet 1. Availability zone, I'm this Ohio region, so I'm selecting for this USS 2A. Okay, CIDR range, I have to select the this subnets IP range or CIDR for IP range or CIDR block is 10.0.1.0/24. Here we will get 256 IPs. Okay, then okay, add a new subnet. I'll do the same. KC public subnet 1, I'll write 2. Availability zone will be same. Okay, public, so I use different availability zone. Then it was what 1. I will use 10.0.2.0 slash 24. Okay, 26 IPs, and then I have created 2 public subnet. Now I'll create 2 more private subnet. Okay, see, private subnet 1, then availability zone will be 2A. Okay, then 10.0.3.0/24 CIDR range. After that, do the same public private subnet 2, availability zone 2B, 10.0.4.0/24. Okay, now let's create these subnets. Filters. So we can see we have 4 subnets and 1 is default subnet in another VPC, which is our default VPC, and this is this VPC. Okay, if we scroll here, you can see we have 251 IP addresses in each subnet, but we have seen that there are 256 IP addresses. So where is rest of 5 IP addresses? We know there are 2 IP addresses reserved for broadcast and gateway, but where is rest 3? What is rest 3 IP address is doing here? You can tell this in the comment section. Okay, route tables. Before creating route table, I am going to create internet gateway. Okay, we have created this green, 2 green and 2 blue subnets in 2 different regions. Why 2 different regions? Availability zone, because we want to make sure the availability of this of our infrastructure, because if one availability zone somehow goes down, we have to make sure the other availability zone is running, so that our service is available always, to make sure our service is available always. Okay, then internet gateway, we will now create this internet gateway by which we can connect to the internet. Okay, see, internet gateway, okay, say GW. Okay, we have created internet gateway. Now we have to attach the gateway with our VPC. Okay, so KC VPC. So we have attached the gateway with our VPC. We can see this through KC VPC, then resource map. Okay, in resource map we can see that there is VPC, KC VPC, and the subnets, 4 subnets. 2 subnet public private is in US EST2A, 2 public private is in EST2B. 4 of these is connected with RTB 0A, this route table, and there is one more. There is a gateway which we have connected with this VPC, against IGW. Okay, now we have to connect this gateway with a route table, which route table will be connected with public subnet. Okay, so we will now create route tables. Okay, create route table. Now RT VPC, KC VPC, and okay, KC public route table, public RTB. Okay, route table is created. Now we will associate the subnets with this route table. I have created this route table for public subnet. Okay, so KC public subnet. Okay, so we have selected the public subnets. So we have attached these two subnet with this route table, and now we will edit the route. Okay, here you can see that any local traffic, okay, any traffic that is going to this site range, any IP address in any device in the network, in this in this two subnet, okay, want to go in this IP, in this site range. If they want to go in this site range, they will be they can go to any, they can connect to any other subnets in the cloud, in the VPC. Okay, so but if the destination IP from any device in this VPC or in this subnet wants to go outside of this site range, then what will it do? Okay, we have to define this. So 0.0.0.0/0. Okay, that means any interface, any IP address will go to where? Internet gateway, and we have to select the internet gateway with KC IDW. We have selected the internet gateway. So first it will check this rule. Okay, if the rule fails, then it will check this rule. Okay, this rule will check, and it can go to internet. Okay, then I'm saving the changes. So we can see that yeah, these two rules are there. So what I'm saying is this public subnet and this public subnet, these two public subnet, there if any devices inside this public subnet and inside this public subnet or inside this public subnet want to connect to any devices inside this VPC, they will go to this route table, and this route table will send check with this route table, will check the rules and send to in local IP address, local machine. If the IP address is 10.0.0.0/16 in this CIDR range, it will send inside this VPC. Okay, yeah, if the IP address is outside this that CIDR range, then it will send the traffic to this router. Okay, we don't have to define this router. When we created the gateway, this router was already created in the VPC. So when we attach the gateway with the in the route table, and if we define the rule, then the IP address outside the CIDR range will go to here, the gateway, using the router, and the gateway will send the traffic to the destination. Okay, then although we have done this, now we have to create a route table for the private subnet, so that the private subnet can communicate with the other subnets in the cloud. But actually it can communicate with the other subnets, because route table, let's go to route table. Because there is already a main subnet. Okay, this is our cloud, KC VPC. Here there is a main route table. There is a main route table that defines the rule that if any IP in this CIDR range, if any IP destination address is in this CIDR range, then it can go to local any local machine inside the VPC. Okay, it can connect to any local machine. So this is the main route table. Okay, now we have if we see if we see this, then we can, if we refreshing this. Okay, yeah, we can see the public subnet to public subnet is connected with this KC public route table. The other subnets are connected with this, the main subnet in the VPC. Okay, the main subnet is defining the rules of the where the private subnet can connect, and when we have selected the public subnet route table, public route table for this public subnet. Okay, so I will create a private subnet route table, another route table for the private subnet. So create route table. Create private route table. Then it's selecting the VPC. After that, I'm going to select the private I'm going to attach this route table with the private subnets. So then I'll define the rules, define the routes. For any IP address, for any IP address except this CIDR range will go to the where. Okay, we haven't created a table. Okay, so we are not going to do, we will do this later. So I'm going to save change. Okay, cancel. Then so we can see that we have attached the public route table with the gateway. Okay, so we have done this task. Any devices in the public subnet can will go to the route table, and the route table we if the destination IP address is inside the VPC's CIDR range, then it will send the packet inside the appropriate device. It will route the packet inside the subnet, inside the VPC's appropriate subnet. Okay, if the IP address is outside the CIDR range, then it will send the packet to the gateway, and the gateway will send the packet to the internet. Okay, so what we can do right now, we can create a EC2 instance and attach it with a subnet, with a public subnet, to check if what we are thinking is what we have set up right now is working correctly. So I'm going to EC2 instance, create. So launch instance. KC public EC2. I'm naming my instance is KC public EC2. Then Amazon Linux anyway, or just Ubuntu. Then it is free tier. I'm using free tier, and key pair name I have created key pair. If you key pair already, if you haven't, then also you can create this create new key pair, and then network settings. Okay, we will edit this network settings. The VPC will be not default VPC. We will create our EC2 instance inside our custom VPC, KC VPC. Okay, then subnet, which subnet will be KC public subnet 1. Yes, we will select the public subnet 1. Then auto assign public IP. Yes, we need public IP for the EC2 instance, because we have to connect to this instance. Then firewall, create a security group. Okay, anyway, let's name this security group is what? KC EC2 public SG security group. Okay, then description anyway is the name. Then I can connect it to the machine with SSH. Yeah, okay, nice. Source type, I'm setting source type as my IP address. Only my IP address can connect to the machine. Okay, I will also want to create ICMP. I want to send ICMP packet to the machine. Okay, just from my IP. So the networking configuration is done. Then configure storage. Okay, I cannot configure storage. This storage is EBS volume. We cannot make the volume less than 8 GB. Okay, we have to select 8 GB EBS volume. Then we are done. We can create the instance now. So okay, so the instance so you can see the instance status is pending right now. Okay, after a few seconds the instance is running. Okay, then we will select this and select connect. After that we will SSH, we go to SSH client and then copy this and okay, then run the command. I'm changing the test.pm into AWS because I have changed the file into AWS. Change the name of the file to aws.pm. Okay, so this is the if we go to the instance, you can see this is the public IP address of the instance. Public IP address, this private IP address, which is 10.0.1.2229. Okay, so we can see that we are 10.0.1.29 in Ubuntu. So we are in the machine. Where am I? Ubuntu. Server curl ip.me. Yes, this is my public IP address. You can see, yeah. Okay, so you can see that I am inside this EC2 instance. So I can connect to this EC2 instance. If I ping this EC2 instance, then what will happen? Ping this public IP address. Okay, it can ping the IP address. Okay, so we can ping it. Now if we go to security groups and and yeah, this, and change the inbound rules and remove the ICMP. Okay, delete inbound rules and remove ICMP packet. ICMP, all ICMP packet. I'm just removing the this rule, this inbound rule. Okay, now let's see if we can do ping in this IP address. See, we cannot ping. It is not returning anything. So we need to check if we have allowed the SSH or SSH in port 22 in as inbound rules. Okay, and security groups are stateful. That means if any traffic goes in, it will remember the traffic and allow the traffic to go out, same as outbound rules. If any traffic goes out, it will remember the traffic, if you remember which traffic goes out, and allow if the traffic goes in. Okay, so because the security groups are stateful, but NACLs network NACLs, also network access control list, are not stateful, they are stateless. That means if the traffic if we define inbound rules as SSH, we have to also define outbound rules of SSH. Okay, otherwise we cannot otherwise if a traffic can go in, it cannot go out, because because it will not remember which traffic came in or out. Okay, I think that makes sense. So we have to check that we can connect to the machine. Okay, so I'm getting out from that machine, VPC. So now we will create a NAT in our, okay, I'm just, now we'll create a NAT, this NAT in a public subnet. Okay, we'll create this NAT in a public subnet. Now this subnet can be we can create the NAT here or here, it doesn't bother, it doesn't make any difference. We can create NAT in both subnets. Okay, but I am going to create the NAT here. We are going to create the NAT here, and it will okay. Now what a NAT do? Okay, when I am creating a NAT in a subnet, what it is doing is creating a interface, network interface, which will select an IP from an IP pool and send our traffic to the internet. Why we need NAT? We can see that private EC2 instance in a private subnet cannot connect to the gateway, because the route table that is attached with private subnet is not doesn't have any rule for the gateway, which means route table don't know where the gateway is. Okay, so if we want to, if any device in the subnet, private subnet, want to connect to internet, okay, suppose any device in a private subnet want to connect to internet, but it doesn't any device from the internet should not connect to the private subnet explicitly, then what should we do? We can use this NAT. Okay, so this is we are going to do right now. We'll create a NAT. We'll create NAT. So let's go to Let's go to NAT gateways and create a NAT gateway. Name KC NGW KC NGW. Okay, I can say 01. Select subnet. Now in which subnet we will install this NAT gateway? I'm selecting public subnet 1. Connectivity type public is elastic IP allocation ID. We need an allocation ID because the network interface need to connect to the internet with a public IP. Okay, so we need a public IP. So we are allocating an elastic IP. It will select an IP from IP pool of AWS. Public, private. Okay, connection type public. Then create NAT gateway. Okay, NAT gateway creation is successful. So the NAT gateway is the state is pending. In meanwhile, let's attach the NAT with the private route table, private RTB, then routes, edit route, add route, any IP address except this will go to the NAT gateway, and have created this NAT and selected the NAT. You can see that any IP address except this, any destination IP address except in this range will go to the NAT. Okay. Let's see what's going on. The status of the NAT is still pending. Okay, it will take some time. We'll continue when the NAT is active. Okay, so the state is available. So our NAT has been installed. Now we will create. Okay, so our this configuration has been done. Okay, now we will install an EC2 instance in private subnet. Okay, but there is a problem. What is this problem? Okay. The problem is I am using a free tier. Here, free tier of AWS. So I can only create one EC2 instance. I can only run one EC2 instance at a time. That means if I run this EC2 instance, okay, if I run this EC2 instance, then I cannot connect to this private EC2 instance in the private subnet. Why? Because this EC2 instance will not have any public IP. Okay, this EC2 instance is not connected with the internet. Is not connected with the gateway. Okay, because it is not connected with the gateway, so any connection that is coming to the gateway and the gateway will not know where to send the packet. Will say, because the gateway will get the IP address, the gateway will send this to here, and the route table will not know that which device the route table will not know in which device this EC2 instance is, because the route table is connected with only public subnet. Okay, so the route table will check here there is no public IP for this EC2 instance, so it will drop the packet. So how can we how can we connect to this private subnet? We can do this by running a public subnet here. Then from this public subnet we can connect to this private subnet, but I am running a free tier. That's why I cannot create run I cannot run two EC2 instances at the same time. So how can we check that what we have installed in Net Gateway is actually working? I have figured out a way around for this. I will use that to show that my configuration is correct. Okay, so let's see how I've done this. I'll go to EC2 instance, EC2. Then instances. I'll go to right click and images, images and templates, launch more like this. Okay, then I have to stop the instance, running instance. Okay, so as I have selected the launch mode like this, so all the configuration of my previous instance is now here. I don't have to set up all this again. I'm going to change public to private EC2. Then the image is selected. Then let's say key pair. I will select this. Then let's check in network settings. I this cloud. Then subnet. I will select public to private subnet. Okay, private subnet 1. After that, auto assign a public IP. Enable auto assign public IP. No, I don't need public IP because I cannot connect to that public IP because the EC2 instance will be in a private subnet which is not connected with the gateway. Then as a firewall, existing we will use existing security group. Select existing security group. Okay, it will not be, we don't need to create another because it will be sufficient for our work right now. Then we have to go to advanced details and go to bottom of this page and put a code here. Before that, let's go to webhook.site and okay, I'm going to create new create new URL. I'll copy this URL and paste it here. And then you just have to copy this code and paste it here. Okay, what is this code doing? This code is a bash script, and this will first update the instance, then install the curl if it is not installed, then curl to this URL. Okay, but curl to this URL, that means it will connect to this URL. I will just attach dash data hello from EC2. hello from EC2. Okay, so card data dash data hello from EC2. uh, when the instance will be created, it will run the script, and the script will connect here. Okay, and we will get this message, hello from private EC2. Okay, private private hello from private EC2. Okay, let's launch this. Okay, oh yeah, I haven't stopped this instance. I have to stop this instance. Stopping. I have to wait until it says stopped. Okay, so it is stopped. Now we can retry this. Okay, successful. So we can go here, public private instance, so pending. Okay, so we have to wait until it is running. Okay, the instance state is running, checking status, initializing. So still nothing connected. Okay, after a few minutes, the 2 out of 2 checks passed, and then you can see a post request. Okay, here the content is hello from private EC2, and the IP address is 18.217.21.87. Okay, so we can, if we go to net gateways, and the primary public IPv4 address is 18.217.21.87. so we can see the IP address from from this IP address we have got hello from private EC2 from net gateways IP address. So and now if I want to ping this, will it return anything? No. Now what kind of IP address is this? Let's check. Okay, what is it? bgp dot c.ag.net. If we look for this IP address, to whom this IP addresses belong, we see this IP address is of Amazon Technologies Limited, from autonomous system 16509. Okay, this IP range is there, Amazon's. So that means we can connect to this EC2 instance, but we cannot connect to this EC2. The EC2 instance can connect to the internet, but we cannot connect to this EC2 instance because this EC2 instance is in a subnet where the route table is not connected with the gateway. Also, the EC2 instance does not have any public IPv4 address. Okay, but it can connect to the internet using the net gateway. So if I want to summarize the architecture, that uh, we have we created a VPC. First, we created a VPC. Then we created two subnet in two availability zone and two subnet in two availability zone. Okay. And one more thing, that there is no such thing as public or private subnet. A subnet is public if the gateway routable attached with that subnet is connected with the route or with the gateway. Okay, then we can say that subnet is public. If our routable attached with a subnet is not connected with the gateway, then we say that it is private subnet because it has no direct internet connection with it. Okay. Then we created route table and attached the route table with appropriate subnets. Then we attached the public subnets route table with the gateway. Okay, we created a gateway and then attached the route table with the gateway. Then we created a NAT gateway and attached it with the with a public subnet. The NAT gateway is in a public subnet, and then attached the private subnets route table with the NAT gateway. Okay, so so any device in the public subnet can connect with the internet through NAT. So this is basic architecture, I can say, for learning AWS. Okay, I think you have learned something new today, and hope to see you in next video. Until then, goodbye.